Everyone, welcome to lesson number 19, grade 10 mathematics, new curriculum. And in this video I am going to show you how to complete the square. Now, why should we learn how to complete the square? Now, this technique of completing the square is going to help us to solve quadratic equations or quadratic trinomials that cannot be factorized. So if a quadratic equation or trinomial cannot be factorized, so we use the method called the completing the square. Alright, so also it is going to help us to sketch quadratic functions. Okay, so when we start sketching quadratic functions, so we'll be expected to determine these two x-intercepts, the y-intercept, and the coordinates of the turning point. Okay, so this technique is going to help us to do that. But when you complete the square of any quadratic function or quadratic trinomial, you end up with something like this. So this is the final answer that you should end up with. So meaning that if you are given something like this, ax squared plus bx plus c, and then you are told to complete the square of that, you must end up with that. So this should be the final answer, where a, p, and q can be whole numbers, negative numbers, positive numbers, fractions, depending on how the quadratic trinomial or function is set up. All right. So I'm going to show you two methods, the longer one and the shorter one, of how to complete the square. But first, I am going to show you the one that can be factorized. How do you complete the square of the quadratic trinomial that can be factorized? Okay, so now with that said, let us look at this one. Let's say you are given something like this: x squared plus 6x plus 9. This is a quadratic trinomial. This one can be factorized, but I'm still going to show you how to complete the square of this. So how do you do that? You just write this with 4 terms, so meaning that you're going to find the factors of 9. If you add them up, they'll give you 6, but if you multiply them, they will give you 9. And those factors are 3 and 3, because 3 times 3 should give you 9, and 3 plus 3 should give you 6. So we are going to replace now that 6 by this x squared plus, sorry for that, 3x plus 3x plus 9. So this is just 6x. So the first two terms have a common factor, which is x plus 3, and then the last two have a common factor, which is x plus 3. Okay, so this is the same as what is inside. So if you factorize out, the common factor will end up with this, with this, which can be written as x plus 3, everything squared. Alright, now remember what we had earlier, that a, x, p, everything squared plus q. So here a is equal to 1. Remember, in mathematics, if there's nothing, there's 1. P is equal to negative 3. So now when this is positive, when you write down the p, you say it's negative. And of course q is equal to 0 because there's nothing. So we call that this is a perfect square, because it can be written in this form and there is no q. Q is just 0. Alright, so what I'm going to show you now, I'm going to show you the next example. In the next example, a quadratic trinomial that cannot be factorized, and that will end up with a q as an integer or another number. So here we have a 0, but I want to show you how we can end up with a number here. Okay, because this one is a perfect square, you end up with 0. Alright, so let us look at that. So with the next example, I'm going to show you the longer method and the shorter method. So it's up to you in the exam which method you are comfortable with. Alright, so now let's do this. Let's say you are given x squared plus 10x plus 7. There's no way you can factorize this. There's no factors of 7. If you add them up, they'll give you 7. And if you multiply them, they'll give you 10. There's no such factors. So that's why we must complete the square. How do you do that? So we are going to introduce two terms here so that this becomes factorizable, so that it will be able to be factorized. So we say x squared plus 10x plus 10 over 2 squared minus 10 over 2 everything squared plus 7. So what I'm trying to do, I want to have 1, 2, 3 terms factorizable, and this I will simplify, okay, as one term. So I have x squared plus 10x plus 25 minus 25 plus 7. If you look at these two terms, they will just cancel each other. They will just cancel each other. Where are they coming from, by the way? 10 divided by 2 is 5. 5 squared is 25. 10 divided by 2 is 5. 5 squared is 25. So meaning that when you are completing the square, you take the b term, you divide by 2, then you square it, then you take it away, b divided by 2, everything squared. So this is our b term. Remember, x squared, ax squared plus bx plus c. So you take the b term, divide by 2, you take it, you introduce it, and you take it away at the same time. Now, if you look at this, that can be factorized. Factors of 25, if you add them up, they'll give you 10, but if you multiply, they'll give you 25, and those factors are 5 and 5. So this can be just brought down and simplified. Okay, let's continue. So factors of 25, they'll give you 10, so that's 5x plus 5x plus 25 minus, remember this should be simplified to minus 18. We factorize by grouping x plus 5 plus 5x plus 5. So the common factor here is x. That's why I factored it out. The common factor here is 5. As you can see, what is inside the bracket is what is outside. That is x plus 5, x plus 5 minus 18. So as you can see, I have now introduced a term so that this 1, 2, 3 I can factorize. Okay, and this 1, 2, they simplify to minus 18. So now this can be written as x plus 5, everything squared minus 18. Because the brackets are the same, I can just put a 2 there. Okay, so now the question is, what is A, what is P, what is Q? Here, obviously A is equal to 1 because there is nothing. P is equal to negative 5. Remember, if it's negative, when you write down the P, you say mine is a negative. If this was negative, when you write it down, it will be positive. And Q is equal to negative 18. So this is the longer method of completing the square. So now I'm going to show you the shorter method of completing the square. Okay, let's do this. So in the exam or in the test, this technique is, or this question will probably be 3 to 4 marks depending on the nature of the quadratic trinomial or the quadratic function or equation. So let me show you the shorter method. So the shorter method requires you to remember these steps. Step number 1, make sure that there is a 1 here. If this is not 1, make sure that you factor it out. So if there was a 2, you are going to factor it out and have x squared with a 1 here. So that is step number 1. You make sure that A is equal to 1. Then the next step, what you do, you say, you open the bracket, you bring this term down. But when you bring it down, you don't bring it down with a square. You only bring it down without the square. Then you bring the sign down as it is, you halve the B, which is going to give you 5. You close the bracket, you square everything, you subtract the square number of this, which is 25. Then you bring down the C as it is, simplify, that should give you minus 18, which we got earlier. So that's a complete square of that. Alright, so my friends, in the next video, I am going to show you how to complete the square when a is bigger than 1. For instance, how do you complete the square of this? We have 16x minus 9. So as you can see that a is 2, so you must factor it out so that there is a 1 there. Okay, so that is what we are going to do in the next video. Thank you for watching and see you in the next video. Remember to leave your comment in the comment box, and if there are any questions, please, my number is on the channel, and let's get in touch. Thank you for watching, and bye bye.